Hello, welcome back. So in this part, again, we will continue our design requirements. Now we will see the next requirement, which is related to the spacing of the batten. Well, how do we find out the spacing of batten? Well, the same requirement is for lacing also. So there we are using the same requirement, which is for lacing also. So as per IS code, it says that the spacing of batten, which is C, it should be such that the slenderness ratio of the lesser main component over the distance is not greater than 50 or zero 0.7 times of slenderness ratio of the main component as a whole. So the same I have explained in the lacing system also. The same formula we are using here. In the lacing system, it was used L in place of C, but in this case, as we are discussing about the batten system, L is replaced by the C. So the same formula we are using here also. So C by RC minimum, it should be less than 50 or 0.7 times of lambda. This lambda is the slenderness ratio of the whole column, which is KL by R. Effective slenderness ratio of the column. And this RC minimum, it will be the minimum radius of gyration for the individual component, say this channel section. So this channel section will have its own RYY value, RZZ value. So minimum of RYY and RZZ will be the value of this one. So using this relation, we can easily find out the value of C. So we will see how do we find out this C value using when we will discuss about the example. We will take an example. Next is the end connections. Well, when we use the batten system in the built-up column, we also supposed to design the end connections. Like now these end connection may be in the form of welding, maybe in the form of rivets or bolts. So in case of batten system, we design the end connections for VL and M. Now what is VL? VL is the longitudinal shear force and M is the moment. And as I have discussed earlier also, this VL and M, both of these are due to the provision of transverse shear. So now in this end connection, if we are supposed to design a welding connection, if we are supposed to design bolted connection, how do we design that? That is all about it. So now, as per this clause, IS code has suggested some specifications for the welding. Now it says when we connect the main member by welds, the length of weld connecting each end of batten shall not be less than the half the depth of the plate. Now I will show you that using the diagram. It says here that the value of K, it is actually the length of weld measured in the longitudinal direction, and it says that it should be more than the D by 2. Now I'm showing here K by 3 plus K by 3 plus K by 3. So we are actually measuring the length of weld in this direction. So this is what IS code has suggested, that we should measure the length of weld longitudinally. So this direction is longitudinal direction. So we are actually measuring the length of weld in this direction. And now I'm taking the length of weld as K, and this K should be more than D by 2. This is what IS code has suggested, that when we connect the member with weld, the length of weld connecting each end of the batten shall not be less than half the depth of the plate. So this capital D is actually the depth of plate. Now second point, it says that at least one third of its length should be placed at each end. Now the length which I am discussing this, it says this K. So it says at least one third of its length, which means K by 3. It should be provided or placed at each end of the edge. So this is the end of this edge. So at each end we are providing K by 3, one third and one third on both ends. So the remaining length we are providing in the middle. So this is how it says Then next point, it is written here, in addition, to this point, in addition, the weld shall be returned along the other two edges for a length not less than the minimum length. Now the other edge is this one and this one. So it says the length that is returning on the other edge, it should not be less than, the minimum overlap, which is 4 times of T. Now T is the thickness of batten. So the same thing IS code has suggested, and based on that suggestion, I have made this diagram, and that is how we have to follow. And the same point that I have discussed, the length of weld and depth of the batten should be measured along the longitudinal axis. So this axis is longitudinal, so we are measuring the length of weld in this direction only. This is what IS code has suggested. So that is the specification for the welding as per IS code. Now, if we are providing the bolted connection, in that case, we have to design bolts, and we have to design bolts for resistance against the longitudinal shear and the moment. So when we connect the main member with the bolt or rivet, in that case, what we are supposed to find out, first of all, we find out the number of bolt. Now number of bolt can be calculated by using this formula, which is transverse shear by bolt value. So using this, we will find out the number of bolt. Then second, we will check the bolt connection for the combined effect of transverse shear and sorry, this is not transverse, it is actually longitudinal, which is VL, and this is also longitudinal. So longitudinal shear. So transverse shear is basically 2.5% of the axial load, and because of this transverse shear, the two effects induces, one is the longitudinal shear and the other is moment. Now I will show you that through the diagram also. This is the transverse shear, and because of this transverse shear, first effect is this one, which is longitudinal shear, which I am representing by VL, and the next effect is because of the moment, this M. So we design our bolt connection to resist this effect and this effect. Now, because of this transverse shear, as we know that longitudinal shear force and moment is inducing. So these longitudinal shear and moment, they're actually creating two types of force. One is F1 and the second one is F2. Well, this F2 is because of the value of VL, and this F1 is because of the value of M. So ultimately, these two effects will be acting on the bolted connection at the same time. So what we do is we actually find out the combined effect of them. So F1 will generally act in this direction, F2 will generally act in this direction, and the angle between them will be theta, which is generally 90 degree. So the resultant of F1 and F2 will be Fr. So we will find out the value of Fr, and this Fr should be less than the value of bolt. So I'm saying here that Fr should be less than bolt value. Bolt value is actually the strength of bolt. So whichever bolt we are using, the strength of bolt should be more than the resultant effect, the resultant force due to the effect of longitudinal shear and the moment. Now, how do we find out F1? F1 can easily be found out using the formula mr by summation of r square. Now, what is r and what is summation of r square, that we need to understand. Now, F1, as I said, F1 is m into r by summation of r. If we take, if I take the enlarged version here. Say these are the 4 bolt, and transfer shear is acting through this. So it is actually acting at the CG of the bolt. So this is the CG of the bolt. And generally, the moment which is induced because of this transverse shear, the effect of moment will be maximum at the extreme bolt. So from the CG, the extreme bolt will be this one. So this bolt will be the most critical bolt, and it will experience the maximum effect of the moment, which I am representing as F1. So the force due to the moment I am representing as F1, and the same bolt will also experience the effect of longitudinal shear, which I am representing here F2. So to find out the value of F1, we will use this formula. And what is R? R is the distance of bolt. For example, if I am finding the force for this bolt, then the R will be distance between the CG of bolt group and the extreme bolt. So this one is the R. Similarly, the summation of R will be, for example, from this CG, all bolt will have a particular distance, say R1 and R2. Similarly, this also R1 and R2. Sorry, this R2. So in that case, how do we find out R? Sorry, this is summation of R square. So this summation of R we can find out as R1 square plus R1 plus R2 whole square. So this is how we find out the summation of R square. So this is actually the relation. I mean, in the bolted connection, there is a topic of eccentric connection design. So when we are designing bolt connection for eccentric load, in that case, we use these formula to find out the effect of force, I mean, effect of moment on a particular bolt. So this formula we use, and R is the distance, I mean, whichever bolt for the effect of moment, if we are, say, there are different bolt, okay, and all the bolts will experience different moment. So if I am supposed to find out effect of moment at this bolt, so in that case the CG of the bolt group will be this one. So force is acting at this one. So distance from the CG to this bolt will be R. Similarly, this will also be R. This will be, say, R1. Similarly, this will be R1. So the summation of all these distance, square of the summation of all these distance will be called summation of R square. So this is what I am calculating in this case. Okay. So we will see this in the when we will solve the example. So F1 is due to the effect of moment, F2 is due to the effect of longitudinal shear, and for bolt to be safe in combined effect, FR should be less than the bolt value. So this is the requirement. This is the this is the major requirement that we have to satisfy. Well, after estimating the size of batten, we are supposed to check whether the size that we have adopted for the batten, if they are safe or if it is safe or not. So in that case, what we do is, as we know that batten plate will experience the longitudinal shear effect and the moment effect. So what we do is we find out the actual shear stress and actual bending stress, and then we have to satisfy that with the permissible limit as per IS code. So for shear stress, which is because of the VL value, so we find out the shear stress as this formula, which is force upon area of cross section of the plate. So here the force is longitudinal shear force, and shear stress we are actually calculating. So that is because of the longitudinal shear force, and divided by area of cross section. So from this we can find out the shear stress, and this calculated shear stress should be less than this value. This is the permissible shear stress in the steel as per IS code. And then in the second point, we have to find out the actual bending stress, and this actual bending stress should be less than the permissible bending stress. So permissible bending stress as per IS code is Fy by gamma m naught. Gamma m naught value is 1.1, and Fy is the yield strength of the steel. Now, how do we find out the bending stress? Bending stress, I hope you remember, in the when we use simple bending equation. So simple bending equation is m by I, F by Y is equals to E by R. So if we take these two value, in that case, this F is the stress. So if we call this FB, bending stress, so FB will be equals to M into Y by I. And we know that Z is equals to I by Y. Now, I is the moment of inertia, and Y is the distance from neutral axis of, say, I'm taking an example of rectangle beam. So in that case, this is the neutral axis, and this is the depth, say D, and this time I'm taking this as, say, T. T is the thickness. Okay, so in that case, if we have to find out the moment of inertia about this neutral axis, then it would be Z is equals to I by Y. So I is moment of inertia about the neutral axis, which is BD cube by 12 upon Y. Y is the distance from neutral axis to the point where we have to find out the stress. So stress is maximum at the edges, at the topmost fiber, or the lowermost fiber. So distance, this is Y, and this Y is actually the D by 2. So I'm writing this is capital D by 2. So after solving it, it becomes BD square by 6. So now FB is equals to M by Z, and I can write as M by BD square by 6. 6 will go up, so it becomes M into 6. So 6M by BD square, that becomes the bending stress for a rectangular section. So in our case, most of the time the batten plate that we will be using, it will be rectangular in shape, which means it will be having a proper thickness and depth. So in that case, M by Z will be 6M into BD square. So this is how we find out the bending stress. This is actually a topic of strength of material. So this has been discussed earlier also. So based on this, we find out this. So this FB value should be less than this one. If it is less than this, then we can say that the size of batten is safe. Otherwise, we have to revise the size. So that was it from this part. So we will continue our discussion in the next part. Thank you.